Sometimes we wish to extract or label the brain based on its underlying tissue types or identify different brain regions and structures. This process of partitioning the brain into these different tissue types, brain regions, or cortical parcellations is called image segmentation. An example of an MRI image segmented into 3 tissue types, namely cerebrospinal fluid or CSF, gray matter, and white matter, is shown here. In practice, this image segmentation can be binary, where the resulting segmentation or brain label is either the region/tissue type of interest or it is not. Alternatively, image segmentations like the one seen here can provide an intensity or probability of an individual voxel being part of a certain tissue type. Images like this are generally referred to as partial volume maps. Voxel intensities in these types of images range from 0, corresponding to not being part of the tissue type, to a value of 1, corresponding to only being that tissue type. Values in between can be thought of the probability of being part of one tissue type or another. For example, in the gray matter segmentation, notice that the caudate has a darker intensity than, say, the cortex. In this example, the segmentation algorithm is reporting that there is a high probability that the caudate is part of gray matter tissue type. However, it is unable to classify it completely as gray matter. Typically, we can use these partial volume maps along with a threshold to create binary labels of, in this case, the 3 tissue types or regions of interest. So how do we perform image segmentation? And you guessed it, FSL would have tools to do this. In particular, we will focus on the FIMBRIB's automated segmentation tool, or for short, FAST, which performs 3D segmentation into different brain tissue types. It's fully automated and can be run both from the FSL GUI or the terminal. If you type FAST into the terminal and hit enter, you'll notice the various options that are available when running this tool. The wiki page and user guide are also great resources for checking out what FAST can do. In the lab, we will take the output that we generated from the previous image registration step and apply FAST to it using the following commands. When you've finished, when FAST finishes, you should see 6 images that get created. Open these files up in FSL and determine which of the 3 distinct tissue types these images correspond to. What do the others correspond to? Include these results in the results section of your lab report.